work for providing
project-based learning,
digital transformation through innovation,
electronics for societal empowerment,
academic diligence, research prominence, industry consumption,
technological excellence for betterment of mankind,
pragmatic learning, societal projects and industry connect.
Acquire technology zenith,
manufacturing automation and management.
You dream it, we build it through functional excellence.
activity-based learning of science.
Robotics and Automation, School of Nano Engineering, and School of Design are our future plans.
College of Engineering started a program in collaboration with Tata Consultancy Services, and in future we plan to start several programs in collaboration with multinationals.
Students here are very energetic and enthusiastic, and they have grabbed awards at various competitions in IITs, in IIMs, in cultural as well as sports competitions.
Our objective is not to create only employable graduates, but job creators also.
And this is the way we charge our students with dynamic education for their bright future.
Bharti Vidyapeeth University, College of Engineering, Pune, creating engineers for tomorrow.
This is the place from where I began my journey. The place that taught me good values and shaped me into a confident individual. It was a supporting hand in my growth. This is the place that made me from a job seeker to a job giver. Now I want to take this journey ahead by mentoring the young students and sponsoring the projects of the bright minds. I am the alumni of Bharti Vidyapeeth University, College of Engineering, Pune.
Bharti Vidyapeeth University, College of Engineering, Pune, creating engineers for tomorrow.
There are so many college options, but I really want a college that will make me a good engineer so that I can work on life projects and contribute as a good engineer of tomorrow.
A college that has latest equipment to learn through the experiments, giving me practical knowledge, but
where can I get such a college?
For all your needs, with latest laboratory facilities and equipments, where students conduct experiments and learn through practical study and research. The answer is Bharti Vidyapeeth Deemed University, College of Engineering, Pune, transforming students for a better tomorrow.
इतने साल से पढ़ा रहा हूं, आजकल थोड़ा डर सा लग रहा है कि स्टूडेंट्स सिर्फ एग्जाम पास होने के लिए तो नहीं पढ़ रहे।
My topic was radar, and again speaking about radar. In radar, it is basically used in defense system and again
मैं हमेशा से कहता आया हूं, इंजीनियरिंग सिर्फ एक डिग्री नहीं है, ये एक अपॉर्चुनिटी है टू जनरेट न्यू आइडियाज टू मेक लाइफ्स बेटर।
A man of foresight, Honorable Dr. Patangrao Kadam Sahab, established Bharati Vidyapeeth in 1964, the vision, social transformation through dynamic education. His dream came into the reality. In 1996, the Government of India granted status of university to Bharati Vidyapeeth.
Today, students from extremely diverse backgrounds are experiencing life transformation curricula in our college.
Curriculum here is purely industry oriented. Internship to the students, industrial training, involvement of the industry experts, guest lectures, live projects are integrated part of our curriculum. The day on which the student enter in this institute, we see that how he become industry ready by the time he graduates from this institute. Now we are going one step ahead and we are trying to make more and more entrepreneurs from this institute. In last 10 years, this institute has produced 1067 entrepreneurs. So practically 100 entrepreneurs per year. As a result of student performance, quality of teaching learning process, quality of faculty members, research, National Board of Accreditation has accredited our program in all its 3 cycles.
Bharati Vidyapeeth University ranked among top 100 universities of India by NIRF for consistently 3 years.
So we all departments together work for providing
project-based learning, digital transformation through innovation,
electronics for societal empowerment,
academic diligence, research prominence, industry consumption.
Technological excellence for betterment of mankind.
Pragmatic learning, societal projects and industry connect.
Acquire technology zenith.
Manufacturing automation and management.
You dream it, we build it through functional excellence.
Activity-based learning of science.
Robotics and automation, School of Nano Engineering, and School of Design are our future plans.
College of Engineering started a program in collaboration with Tata Consultancy Services, and in future we plan to start several programs in collaboration with multinationals.
Students here are very energetic and enthusiastic, and they have grabbed awards at various competitions in IITs, in IIMs, in cultural as well as sports competitions.
Our objective is not to create only employable graduates, but job creators also.
And this is the way we charge our students with dynamic education for their bright future.
Bharti Vidyapeeth University, College of Engineering, Pune, creating engineers for tomorrow.
This is the place from where I began my journey, the place that taught me good values and shaped me.
Good morning, everyone. We'll be starting the program within a few minutes. Kindly bear with us. We'll be starting the program within a few minutes.
Into a confident individual. It was a supporting hand in my growth. This is the place that made me from a job seeker to a job giver. Now I want to take this journey ahead by mentoring the young students and sponsoring the projects of the bright minds. I am the alumni of Bharti Vidyapeeth University, College of Engineering, Pune.
Bharti Vidyapeeth University, College of Engineering, Pune, creating engineers for tomorrow.
There are so many college options, but I really want a college that will make me a good engineer so that I can work on life projects and contribute as a good engineer of tomorrow.
A college that has latest equipment to learn. For the experiments, giving me practical knowledge, but
where can I get such a college?
For all your needs, with latest laboratory facilities and equipments, where students conduct experiments and learn through practical study and research. Answer is Bharti Vidyapeeth Deemed University, College of Engineering, Pune, transforming students for a better tomorrow.
इतने साल से पढ़ा रहा हूं, आजकल थोड़ा डर सा लग रहा है कि स्टूडेंट्स सिर्फ एग्जाम पास होने के लिए तो नहीं पढ़ रहे।
So my topic was radar, and again speaking about radar. In radar, it is basically used in defense system and again.
मैं हमेशा से कहता आया हूं, इंजीनियरिंग सिर्फ एक डिग्री नहीं है, ये एक अपॉर्चुनिटी है टू जनरेट न्यू आइडियाज टू मेक लाइफ्स बेटर। ये देखो भाई, यहाँ पे ये बच्चे ई रिक्शा की बैटरी कैसे और एफिशिएंट करें ये सोच रहे हैं, और मैं वही पुरानी बात। भारतीय विद्यापीठ यूनिवर्सिटी कॉलेज ऑफ इंजीनियरिंग, जहां हम सिर्फ इंजीनियरिंग नहीं पढ़ाते, हम नए आइडियाज को बढ़ाते हैं। अगर भारतीय है तो मुमकिन है।
A man of foresight, Honorable Dr. Patangrao Kadam Sahab, established the Vidyapith in 19 through dynamic education. In reality, 1996, the government city Bharti
diverse backgrounds or life
Curriculum here is purely industry oriented. Internship to the students, industrial involvement of the industry experts, guest lectures and projects are integrated part of our curriculum. The day on which the student enter in this institute, we see that how he become industry ready by the time he graduates. We are trying to make more and more entrepreneurs from this institute. Last 10 years, this institute has produced 1067 entrepreneurs. So practically 100 entrepreneurs per year. As a result of student performance, quality of teaching learning process, quality of faculty members, research, National Board of Accreditation has accredited our program in all its 3 cycles.
Bharati Vidyapith University ranked among top 100 universities of India by NIRF for consistently 3 years.
So we all departments together work for providing
project-based learning, digital transformation through innovation,
electronics for societal empowerment,
academic diligence, research prominence, industry consumption,
technological excellence for betterment of mankind,
pragmatic learning, societal projects and industry connect,
acquire technology zenith,
manufacturing automation and management,
You dream it, we build it through functional excellence.
activity-based learning of science,
Robotics and Automation, School of Nano Engineering, and School of Design are our future plans.
College of Engineering started a program in collaboration with Tata Consultancy Services, and in future we plan to start several programs in collaboration with multinationals.
Students here are very energetic and enthusiastic, and they have grabbed awards at various competitions in IITs, in IIMs, in cultural as well as sports competitions.
Our objective is not to create only employable graduates, but job creators also.
And this is the way we charge our students with dynamic education for their bright future.
Bharati Vidyapith University, College of Engineering, Pune, creating engineers for tomorrow.
Good morning, everyone. The session will begin within a few minutes. Kindly bear with us. In the meanwhile, all the participants are requested to please mute their mics. We'll begin the session in a few minutes.
This is the place from where I began my journey. The place that taught me good values and shaped me into a confident individual. It was a supporting hand in my growth. This is the place that made me from a job seeker to a job giver. Now I want to take this journey ahead by mentoring the young students and sponsoring the projects of the bright minds. I am the alumni of Bharati Vidyapith University, College of Engineering, Pune.
Bharati Vidyapith University, College of Engineering, Pune, creating for tomorrow.
There are so many college options, but I really want a college that will make me a good engineer so that I can work on life projects and contribute as a good engineer of tomorrow.
A college that has latest equipment to learn through the experiments, giving me practical knowledge. But
where can I get such a college?
For all your needs, with latest laboratory facilities and equipments, where students conduct experiments and learn through practical study and research. The answer is Bharati Vidyapith Deemed University, College of Engineering, Pune, transforming students for a better tomorrow.
इतने साल से पढ़ा रहा हूं, आजकल थोड़ा डर सा लग रहा है कि स्टूडेंट्स सिर्फ एग्जाम पास होने के लिए तो नहीं पढ़ रहे।
My topic was radar, and again speaking about radar. In radar, it is basically used in defense system and again.
मैं हमेशा से कहता आया हूं, इंजीनियरिंग सिर्फ एक डिग्री नहीं है, ये एक अपॉर्चुनिटी है टू जनरेट न्यू आइडियाज टू मेक लाइफ्स बेटर। ये देखो भाई, यहाँ पे ये बच्चे ई रिक्शा की बैटरी कैसे और एफिशिएंट करें, ये सोच रहे हैं, और मैं वही पुरानी बात। भारती विद्यापीठ यूनिवर्सिटी, कॉलेज ऑफ इंजीनियरिंग, जहां हम सिर्फ इंजीनियरिंग नहीं पढ़ाते, हम नए आइडियाज को बढ़ाते हैं। अगर भारती है तो मुमकिन है।
A man of foresight, Honorable Dr. Patangrao Kadam Sahab, established Bharati Vidyapeeth in 1964, the vision, social transformation through dynamic education. His dream came into the reality. In 1996, the Government of India granted status of university to Bharati Vidyapeeth.
Today, students from extremely diverse backgrounds are experiencing life transformation curricula in our college.
Curriculum here is purely industry oriented. Internship to the students, industrial training, involvement of the industry experts, guest lectures, live projects are integrated part of our curriculum. The day on which the student enter in this institute, we see that how he become industry ready by the time he graduates from this institute. Now we are going one step ahead and we are trying to make more and more entrepreneurs from this institute. Last 10 years, this institute has produced 1067 entrepreneurs. So practically 100 entrepreneurs per year. As a result of student performance, quality of teaching learning process, quality of faculty members, research, National Board of Accreditation has accredited our program in all its 3 cycles.
Bharati Vidyapeeth University ranked among top 100 universities of India by NIRF for consistently 3 years.
So we all departments together work for providing
project-based learning, digital transformation through innovation,
electronics for societal empowerment,
academic diligence, research prominence, industry consumption,
technological excellence for betterment of mankind.
pragmatic learning, societal projects, and industry connect.
Acquire technology zenith. Manufacturing automation and management.
You dream it, we build it through functional excellence.
Activity-based learning of science.
Robotics and Automation, School of Nano Engineering, and School of Design are our future plans.
College of Engineering started a program in collaboration with Tata Consultancy Services, and in future we plan to start several programs in collaboration with multinationals.
Students here are very energetic and enthusiastic, and they have grabbed awards at various competitions in IITs, in IIMs, in cultural.
Hello, good morning to all. I'm SK Saha this side. Sutar, are you there? Dr. Sutar?
Yes, sir.
Yeah.
Good morning, sir. Good morning, sir. So we'll just begin in a couple of minutes.
Yeah, no problem.
गुड मॉर्निंग शाह सर.
गुड मॉर्निंग, कैसे है?
या एकदम ठीक हूँ सर, आप कैसे?
बस ठीक हो.
Good morning, everyone. I, Professor Ashwin Nayak, on behalf of Department of Mechanical Engineering, Bharati Vidyapeeth College of Engineering, Pune, welcome you all for this FDP on research opportunities in robotics and automation. Robotics influences every aspect of our home and work during these days. Robotics has the potential to positively transform the lives and work practices, raise efficiency and safety levels, and provide us with enhanced levels of service. So this FDP is aimed to provide us the research opportunities that are taking place in this particular. We have with us as GS Professor S.K. Saha. What do I tell you about this case? this guest is one of the best people to talk about robotics in this country. If I just read his biodata, that would take us this entire FDP. He has so many achievements. Equally, we also have another guest with us at the similar level, Dr. S.S. Saha, who is the professor at COE in Pune. He's a guest of honor and he's the coordinator, currently the coordinator for TechWeek 3, and he has an immense experience. And now I welcome both of these guests. I welcome you, sir, for coming to this FDP. Now I request our HOD, Dr. KB Suta, sir, to kindly address the audience.
Good morning all. On behalf of Department of Mechanical Engineering, Bharati Vidyapeeth deemed to be University College of Engineering, Pune, it is indeed a great pleasure for me to welcome Professor S.K. Saha, IIT Delhi, and Professor S.S. Ohal, COEP, and all participants for the inaugural function of this 5 days online FDP on research opportunities in robotics and automation. Sir, Bharati Vidyapeeth, the parent body of Bharati Vidyapeeth deemed to be university, was established by a visionary leader, Honorable Dr. Patangrao Kadam, on 10th May 1964 with the mission of social transformation through dynamic education. The university started functioning on 26th April 1996 and has earned reputation of being one of the top universities in India and achieved A-grade university status by MHRD, Government of India, in 2012. The university was accredited in 2004 and 2011 with A-grade status by National Assessment and Accreditation Council, NAAC. In 2017, the university has accredited by prestigious A+ grade by NAAC during the third cycle of accreditation. Bharati Vidyapeeth, deemed to be University College of Engineering, Pune, was established in 1983. It has been ranked at 99th level by National Institutional Ranking Framework in 2020. DataQuest, Times of India, and other rankings have also ranked this institute among the top 100 institutions in India. AICTE Internshala ranked the institute at 6th level at national level and first in the Western Zone due to strong internship program. The institute was selected by MHRD for the Technical Education Quality Improvement Program TechUp2 for the grant of ₹6 crores. This institute offers 13 graduate and 8 postgraduate programs and doctoral programs in 8 disciplines. All programs are accredited by National Board of Accreditation. This year, the institute has started BTech program in robotics and automation in association with ABB India Limited and Parker Hannifin India Limited. Department of Mechanical Engineering started in 1986 with intake of 60 students at BTech level, which was increased to 120 in 2014. Department also runs MTech program in CAD/CAM and PhD program. 7 faculty members in the department have completed PhDs from reputed universities, whereas the remaining are pursuing PhDs. I'm sure that this FDP will definitely helpful for upgrading our knowledge in the field of robotics and automation. Once again, I welcome you all for this event and hope that you will enjoy all the sessions. Thank you.
Thank you, Sudhanshu. May I now request Dr. S.S. Ohal, sir, to kindly address the gathering. Sir. Ohal, sir, we are unable to hear you. Your mic is muted.
Can you hear me now?
Yes.
Yeah. Good morning, everybody. In today's gathering, Dr. S.K. Saha is there, very close friend of mine. We are working together on many platforms. He is a torchbearer of robotics education in the country. Today, in this gathering, I would like to present few facts about research opportunities as a opening lecture over here in the inauguration function. So I'm sharing my slides. I hope you are able to see these slides.
Yes.
Yeah. So I would like to highlight few of the facts which are there in the field of robotics and automation. We cannot separate robotics from automation. So basically, it's a need-driven industry. Need is there in the society, market is getting driven by that, and industry is catering to all the facts. Need of robotization we are discussing many times, and all these facts are known to all of us. But yes, a recent survey of McKinsey, they are telling that all the needs are of different percentage weightage, such as reduce cost, improve quality. They are having more weightage than that of the others, such as the labor shortage, addressing to the problem of labor shortage, brand perception, and other needs. So these are the basic main drivers triggering the investment in robotics. Then we know that areas of robotizations are there, right from industrial robotics, domestic robotics, then transportation, defense system related robotics, entertainment, until space exploration robotics. In this, in manufacturing, welding operations is a big domain where we are finding various types of welding operations. And over there, major scope is there for research, finding new methods, finding optimized solutions, giving low cost solutions over here to the industry. These are the areas which we can address. Then we also have many issues in material handling in the industry, where we are taking help from AGVs, then automatic conveyor belts, and various types of robots for material handling over there in the industry. And again, many challenges are there, research opportunities are there in material handling also. Then additive technology is also getting good support from robotics. Many different types of systems are there, which few of which I am presenting over here. They are having very good support of robotics technology, and this technology is growing like anything. So research opportunities are there in additive technology, which is supported by robotization. Then special purpose robots are there: inspection, cleaning, then painting, pneumatic muscles, and many things. These are the special robots where I can assure you that people are asking, companies are asking, DRDO laboratories are asking us that can you provide solution for this. In the construction, this is another domain which is untouched till today in Indian domain. So we have good opportunity for research over here in this, right from spray painting, bricklaying, compactors, excavations, floor finishing. Different types of robots are there. Robots which are working together, these synchronized actions and collaborative actions with each other is also a domain where work has not yet started in the industry as a common work pattern. So we have a lot of scope over here. Then innovations, obviously it's a part of robotics, because robotics technology is a cutting edge technology, and many innovations are happening, such as hybrid robots, then very high speed robots, then big robotic systems handling very big objects like sheets and containers, and gantry robots which are handling very heavy duty dies. So there is also a lot of scope. Dual arm robots is coming in the market, and it is also gaining a popularity. Dual arm robots, they are very much popular nowadays because they are giving a feel like human is working with the assembly operation, human is working for material handling, and it is becoming popular. Collaborative robots is another safe technology which allows user to enter in a work volume and work with the robot without any safety threats. This is also giving lot of opportunity for research. So research is everywhere in the industry, and robots are being demanded in the industry and basically by the automobile industry. Therefore, research opportunities are there. According to fresh reports of IFR, July 2020, they are saying that there is a huge requirement of industrial robots, and it is going to have same 12% surprising rate even over there in the coming years. China is a big giant, we all know. Even one factor which we are missing, that job opportunities are getting created by robotics, but at the same time, some technical jobs, mechanical jobs, they are being snatched away because of their job nature. Okay, like salesperson, telemarketers, accountant, auditor, which are typically giving a mechanical solution. So for this repeated type of task, they will be replaced to do some another more skillful job. So this is also another research challenge in front of us. And yes, of course, the people like clergymen, firefighters, photographers, and physicians, they are also being challenged by the increased use of robotics over there. So I would like to present all these facts only just to show you that yes, robotization is getting increased, and in 2025, see, the shipment will be having growth rate of 16%, which is very promising one. So one misunderstanding which is there for the robot, that yes, robots will be creating unemployment, but it is not going to happen. If we compare this with the economy which is boosted because of computerization and because of the industrial automation, same scenario can be there with the robotics technology also. Robotics technology will be entering in almost all walks of life, and it will be giving more opportunity for the jobs. Robot prices are falling nowadays drastically, and we are very sure that was the only factor which is inviting robotics in almost all industry. Annual shipment in worldwide, it is again a very recent survey which is telling us, assuring us that robotics will be there. It will be there in a company and industry in a promising way. At the same time, we should see that what is needed by the customer. So tough challenges which are there in the minds of researcher, they are related with the cost. Very first, customers are demanding less costly robots. Similarly, programming should be comparatively user friendly. Then their integrators and working area should be such a way that it should be comfortable for the work style. Similar type of challenges are there, right from cost of training, contracting the labor force, and safety concerns. So these challenges will be there similarly over there for the researchers also. So I would like to conclude my speech in a brief way that robotics should be simpler to apply. All the potential users, they want very much user-friendly approach while handling robotics technology. Second, it should be simpler to connect. It should be readily available with the industrial connections, such as integration should be easier. And third one, simpler to run. Now, simpler to run means interactive and interconnected interfaces, which are putting even complex programming tasks in hands and making factories less dependent on the existing parameters and departments. So this is the way researchers can contribute more. Lastly, I would like to say that robot decision making, robot object recognition, and robot task completion, these are the technologies, basic technologies, which will be growing in a faster way in a coming era. At the same time, supporting technologies to the basic robotics technology, that is about vision system, AI-based controllers, path planning, swarm technology, self-programming, and making it more user-friendliness can be the promising area. And lastly, required robotic applications. Many applications are there, but these are the few which I have listed over here. Assisting robots, social robotics, also a new term which is arriving in the market, surveillance robots, domestic robots, agriculture, autonomous and surgery robots, and defense, of course. So these are the data which are presented by IFR. They are saying that yes, potential development is going to happen in the coming future, in the near future. So industrial robots are not going to remain like this. They are going to become smarter, like two hands and with camera. Not even that, they will be having mobility also. They will not be standalone. Not even that, they will be interactive, more interactive. And one step ahead, they will be having managerial skills, such a way that they can control activity, they can plan activity. So let us be ready for this research upon opportunity in the field of robotics. Thank you, everybody. Thank you for your patience listening.
Thank you, Ohol sir. That was a very nice presentation that sets the tone for this FDP. Now, I request Professor Dr. S.K. Saha to please address the gathering. So.
Okay, good morning to all, and thank you, Dr. Sutar and the team from Bharati Vidyapeeth for inviting me to this program, and nice to see you, Professor Ohol there. As he said, we are connected in many activities. One of them is favorite to both of us is Robocon. I'll talk more about Robocon today a little bit, and later on during my lecture, I think tomorrow or whenever it is there. Coming back to the program, and I see there are about 40 people around here, 44 I can see, and Professor Ohol has given nice summary of the opportunities. I would like to take you to a little bit of practical aspects, and I would like you to make an effort to do something. When I say do something, one is of course build things to get a hands-on experience, and that's our Robocon experience. Ask your students to build robots for the competitions. When it comes to research, it's not so straightforward, but somebody sometime has to begin. So what I suggest that I will be presenting just after this inaugural session, something called team-based online projects. And the very purpose of doing these both type of activities is to reduce the unemployability, not unemployment, unemployability of Indian engineers. And of course, being a faculty members, we were engineers at certain point of time, to make sure that we are also employable, and not that whatever kind of job we want, we can do that thing. That kind of caliber we should create. India has more than 90% unemployability. We must reduce it, because being one of the youngest country, otherwise we'll be creating trouble for ourselves. So my next half an hour presentation after inauguration will be on that. Other than that, let's have more interaction with other people, and nice to know that Bharati Vidyapeeth has started a BTech program in robotics with an industry. Even though robotics BTech is very focused one, hope the industry will be able to connect to other organizations. And as Professor Ohol said, the application of robotics is endless, and I will show you some during my lectures tomorrow. I think with this brief introduction, and nice to see such activities happening, and please take sincere part in the activities happening in FDP, then only the purpose of FDP will be more effective. So with this, thank you all, and have the best time next few days.
Thank you, Saha sir. I would like to take this opportunity to thank a lot of people. I'll first like to thank Saha sir for being here present in this inauguration function, for guiding us in this FDP. I would like to thank Dr. Ohol sir who was here, who gave us a presentation that set the tone for this FDP, understanding what this FDP is supposed to do. I would like to thank our principal, sir, Dr. Anand Bhalerao, sir, for helping us organize this function. Without his help, this function would not have been possible. At the end, I would like to thank all the faculty involved in making this FDP a success. Thank you, everyone. With this end of this inauguration session, we would start with the sessions. Our first session would be about the introduction to the group activities that we have proposed, and this activity will be guided by Dr. S.K. Saha, sir. So, Saha, sir, if you can guide the participants for this activity.
Yes. So I'll just share the screen first. Okay, so I'll spend about 20-25 minutes to tell you what it is, and then we'll take more questions. So what I call is a team-based online projects, and IT Delhi celebrating Diamond Jubilee, so that's the logo here. And a similar concept with Professor Ohol and Professor Pathak, we have proposed to AICT also, not in the same form what I'm proposing today, but little modified form, because any activity you do, it is important that you do some projects, So I call it a top project to becoming top of the top of the class, top of the world, So that way, nice abbreviation, I could figure it out. Talking about my interest, I have two primary interests. One is, of course, robotics, and another is for the rural activities. So I wanted to introduce the concept of robotic competition-based education in engineering. And I call it innovative teaching because typically we first teach theory and then practice. Can we reverse this process? Can we learn practical things first, then the theory? Then it will be very interesting to me actually. Just like riding a bicycle, if I teach you theory, you're not really able to ride a bicycle, So our education process, I am proposing, if it can be reversed, of course it cannot be changed overnight, but some activities, some can be adapted. First watch what is this robotics I'm talking about.
अच्छा घूमने के लिए नीचे छोटे नीचे हाँ कैस्टर टाइप हमने लगा रखी स्क्रीन वाली साइड हमेशा पीछे होती है हाँ टीएफटी स्क्रीन।
So I'll talk more about this during my formal presentation. So this is a robotic application as a part of Robocon robots, which were built in 2008 and slowly came up to this level, where a company has formed called PR Robotics, and this is a robot is under testing in a hospital. The second activity is related to my research, which is called multibody dynamics, and how the research which is actually used for aircraft modeling and then spacecraft modeling and car modeling. But I wanted to use the same knowledge for rural application. Just watch one application of a device. So this is called a treadle pump used for irrigation purposes. There are many used in Maharashtra as well, West Bengal, Bihar, UP. So in order to design such things, can you do the dynamic modeling and make it efficient? So that's the kind of research I would like to propose, and that's an innovative research, because so far in India, most of the research we are talking about robotics today, most of the research what we do have started in America or Japan 20 years ago. So if you start something today after 20 years, you will always become a follower, never a leader. So to become a leader, you have to start something different. And I consider this kind of research where robotics can also play a role and can be a new dimension in research. So I think this I'll talk tomorrow. This is the video I'll show you tomorrow. But what I'm talking about, the rugby concept, taking part in Doordarshan Robocon. So 2019, IIT Delhi has organized it. Before that, it was held in Pune for many years by MIT. And last 2 years we have been doing it, and 2022 it will be held in New Delhi. So I'm sure many of the Western states are very active in taking part, but if faculty are from the non-Western states, please encourage your students to take part in such activities, which will be very rewarding. To tell you how those robots have slowly become a product, as I shown in the first slide. So 2008, after we came back from Robocon, we asked the students to keep their robots 24 hours in our student activity center, and one such robot is shown here.
Press the red button, enter passcode 1 2 3 4 5. Press red button again.
So 2008 game theme was the Govinda. It was held in India, the international one also. And this arm was used to pick up the butter, the makhan basically, the object. And we have converted it to it as an arm to do the charging in the charging station. And the game, typically the Robocon game is about 3 minutes. But here we wanted to see whether the robots can work tirelessly, 24 hours a day kind of thing. So we kept it in the student activity center to see its reliability and robustness actually. And of course, the one in the first slide you have
Sir,
seen
voice
now.
not audible, sir.
My voice is not audible? Hello?
Yes, sir, audible.
So it's audible. Yes, sir. Continue.
The video voice, ignore it actually. The video has some sound, but don't pick on. I'm explaining that thing, okay? And so you can see that how in the first slide I have showed this robot has now become autonomous, not from following the lines. So then how do we utilize such knowledge for the rural technologies? I have several of those. Maybe I'll show you one here. So this is to make beads from the tulsi stem. You can see how it is getting made.
Hello.
Again, ignore. Hello? Hello?
Yes, sir.
What happened?
No, sir. Please continue.
Yeah, I said they ignore the video sound actually, because there is some setting required. So here what you see is these are the tulsi beads, used for the temples to make malas, and any temple you go, there would be the beads of 108 beads, to do some meditation. So in Kerala in 2016, we wanted to demonstrate that how the modern technologies can be utilized, particularly the robotics technology. So as I'm writing here, so contactless switch. So what you see in this
Sir,
device.
the voice is not audible, sir.
My voice is not audible?
Can you check it your side?
Hello?
Sir, audible, sir.
Sir, it is audible.
So what is not audible?
Yes, sir, you are audible.
Yes, you are audible.
No, what is not audible? Somebody is saying that something is not audible. Hello?
This sir has mentioned that voice for this.
Yes, sir, your voice is audible, sir.
Okay.
Video is not audible. So just
video, I'm not playing the video audio for you actually. I'm explaining what is there in the video. Okay. So what I missed it actually while talking. Yeah.
Yeah. I'm muted.
Yeah, so you can see how this is the tool system here, and then this is the cutting tool. It's like a lathe action. The beads are getting formed, and she's explaining that how easy it is to make. But what I wanted to tell you is robotics technology. You see that she is pressing a button here to make it on and off. And every day, these ladies will be making about 600 to 700 small beads to make the malas. So 600 to 700 times on and off, the mechanical
Sir,
switch
kindly
go
check
back.
your audio system, sir.
Nee, my voice is audible or
Sir,
not?
kindly respond to me.
Yes, sir, we are audible.
Sorry. Yes, sir.
Somebody is telling it's not audible. So Sutar, can you come and then guide me? What is the problem? Dr. Sutar?
Participant, please, it is request to participant, please, if there is audio problem, please check at your side. We are completely audible, sir. Sir, please continue.
Okay. So, so some of these things I will show you tomorrow, but if you go to our website, it's called Rural Technology Action Group. We have a newsletter there. We have the compendium consisting of 52 technologies. No? Okay, so that was little introduction about my activities, showing about two of my interests. One is the robotics related thing and another is the rural related thing. Now I will explain the top activity which will be introduced to you for next few days for your program here, FDP program. Why I have started this kind of activities. I had requested all the organizers, it's a team-based online project. The general quality of India's engineering graduates is exactly where it was a decade ago. On top of a shocking series of revelation is the finding that 80% of the Indian engineers are not fit for any job in the knowledge economy. So this is a information from Economic Times. So this is a really worrisome fact for us, particularly being in the academic domain. So what I am proposing today is the top at Bharti, which is the sixth activity which will be held. The earlier 5 activities have been done. Can everybody put their mic on mute? Hello, can everybody put their mic on mute? So NIT Jamshedpur 2 times, NIT Patna 2 times. I wanted to show you some feedback before I tell you what it is about. So some people are writing after the program, the top got more clarity in the concept.
Right, Kudutaji.
Top activity provides sharing knowledge among teams for best outcome through online. Top interaction and work as a team, hands-on learning. So I'll go back to the top activity after reading some of the feedback.
Now only your voice is audible, sir.
Hello, what is the problem?
Hello.
So again, your voice is not audible.
I think organizers have to take some action. Actually,
kindly check it your side, sir.
Everybody can hear it. It is not you who cannot hear it. What can I do?
Mr. Venkatesh, you can check your settings.
Okay. Shall I continue, Dr. Sutar?
Yes, sir. Yes, sir. Continue.
Can you put everybody on mute? Actually, somebody is telling me not audible. At least if he's not audible, let him tolerate.
Sir, you are on mute, sir. Please start your mic.
Hello. Actually, your voice is
Yeah.
on. Yeah.
So this is correct mute. Okay, no? Okay. So okay. So today actually I have a lecture for NIT Durgapur also. So I have prepared almost similar slides. So what we'll be doing is we'll be dividing you 4 or 5 teams in a team depending on how many participants are there. No? So the organizers under my mentorship, they will do it. So all 44, if there are 44, we'll divide you into 11 teams, 4 in each team. No? Theme of the projects will be the FDP lecture. So you can pick up any one of the lecture theme as your project theme. Type of your project would be either literature survey or algorithm development or design synthesis. Literature survey means, suppose if you take automation in manufacturing, so you can study different literature to see what are the different kind of automations exist and how they are adopted, how it is suitable in Indian scenario, something like that. Algorithm development means if somebody teaches you robot kinematics, for example, you want to write a small program using a Python program or MATLAB program just to see whether you have learned properly or not. Design synthesis means if you wanted to say, for example, design a machine to dispense sanitizing liquids, how that would be looking like. So that's the design synthesis. The idea is after today, by tomorrow, you should be submitting your title and the type of project you will do it to the organizer. And it is expected that every day 30 to 60 minutes you will spend to talk to your colleagues, which are provided by the organizer, 4 in a team or 5 in a team. And at the end of the FDP, you will submit 6 slides in a PDF format. And then peer evaluation will happen, means each team will be evaluated by 2 other teams. Team 1 by team 2 and 3, team 2 is by 3 and 4, and so on and so forth. And on the final day, there will be 2 to 3 minutes discussion will happen on each of the project by the experts. And I'm volunteering to come on that day to see what you have done. And the best team, I am ready to sponsor my books, the best teams, my book on introduction to robotics. If organizers permit me to do that, I will do that. So going back to the feedback again, feedback received, I will show the feedback again. So you can see planning, sharing, analyzing, deciding, coordinating, leading. Does it take us to reach higher? It was a great experience working with my team, and I would definitely like to collaborate in future if opportunity comes. And so after the event was over, I asked each of them, what is the feedback, and that is the feedback which has happened. So now we are taking one step further to make it a professional level. You need not worry about it. But what I'm going to tell you that by a Kolkata-based company, we are taking it to professional level. So it will be happening every 3 months. And we plan to allow registration for first few days free and later on a payment basis. So we have created an international advisory committee to look after. This is just for your information. So whatever you will do today, next few days is the same thing. We are doing it in professional mode. So I wanted to stop here by trying to say that, okay, we are trying to connect engineering minds to the society by interacting through different project modes, either building robots for competition, as I've shown in rugby, or by making systems for the society like Tulsimala bead making machine, or trying to understand that what needs to be done with our knowledge by collaborating with our different faculty colleagues, as I'll be doing it from today on the top program. So with this, I wanted to stop here. I would like to take few questions in whatever next few minutes left in our session. Thank you. If you are not able to talk, you can type in the chat box also. I will answer from there. So we'll spend next 5 minutes to do this thing before I go out from this session. Thank you.
Thank you, Saha sir.
Thank you, sir,
for guiding us in a different ways, and to be have such an activity which will be a practicable in group activity. Definitely we try to implement this, and we will be move toward this rural robotics and whatever the new idea you have been for us. So definitely it will be help to the participants to be have this interactive, and next 5 days they will be gone through it also. So once again, thank you, Dr. Sahasar, and all the
Sorry,
participants.
there is a question here. You want to take it or you wanted to stop it? Vishal Bhagwat raised his hand. You wanted to let him ask or you wanted to stop?
Hello.
Yeah, go ahead.
Okay. Sahasar, you want to say something? Hello.
Vishal Bhagwat has raised his hand. So you wanted to let him ask something or you wanted to stop? That's why I'm asking you.
Yes, sir. If participants, any participants, you want to ask something?
No, he left.
Okay. So can we continue?
Yeah. Okay. So is it okay? I can leave then?
Yes, sir. Yes. It's okay. Thank you, sir. Once again.
Thank you. And so next is Professor Ohol's presentation.
Yes, sir.
Yeah. Sir is coming. So let me start.
Yeah. So please, thank you all. And my presentation is tomorrow, right? So I'll see you tomorrow.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
Maybe I'll spend 5 minutes with the whole, no?
Yes,
and I'll
sir.
quite go out. Okay.
No problem.
Yeah.
Okay.
Thank you. Bye.
Moving towards next session. Good morning to all. I, Professor Yura Thora, welcome you all on behalf of Bharati Vidyapit, deemed to be University College of Engineering, Pune, for 5 days Atal FDP on research opportunities in robotic and automation, organized by Department of Mechanical Engineering. I would like to welcome our today's first resource person, Dr. S.S. Oher from Government College of Engineering, Pune. He is in mechanical engineering, having area of interest mainly as robotic, automation, mechatronics, machine drawing, and computer graphics. He has also completed his BE mechanical and post-graduation in Government College of Engineering under Savitribai Phule, Pune University. His doctoral research was first pioneering one in area of robotics in mechanical engineering at Pune University. Also, taking an insight of his professional experience, presently Dr. S.S. Oher is an associate professor in mechanical engineering department of College of Engineering, Pune. He is faculty advisor for few technical and co-curricular activities at Institute. Presently is procurement coordinator of the Institute for TCube 3, a World Bank associated project of Government of India. He has vast experience of 24 years in technical education, and he has been guided PhD candidates also under his supervision over 40 students for PG courses also. He has successfully completed challenging research project with DRDO laboratories of Government of India in the area of robotics and automation. Few of his research papers have been awarded with best paper or excellent of this conference award at national and international conferences. Apart from academic membership in reputed technical association, he is sharing his expertise with government and non-government bodies and industries also. Active association with armament design, mechanism and ballistics, a panel member of Armament Research Board, DRDO India, a member of PGD 18 Committee of Bureau of Indian Standards, India, that is BIS, a member of panel of Chief Judge as Robocon, a national robotic competition organized by Doordarshan India with ABU International for Robotic Competition and zonal editor of newsletter of Association for Machine and Mechanism shows his commitment for Technical Society of Nation. Such a great personality is with us for first session. Without taking much more time again in this introduction itself, I welcome you all participants and sir, request you to take the charge of this first session to enlighten us. Thank you.
Thank you very much. Once again, good morning to all of you. It was a bit lengthy biodata reading, and it was embarrassing for me to have my details in front of Dr. Saha sir. He is a good friend of mine, as I told you, and his innovative ideas in the field of education are always helping us. We are working together, as I said, in many platforms. So in front of him, putting my achievements was comparatively bit making me nervous. Okay, so with the permission of Saha sir, I am starting this lecture.
Yeah, all
Okay,
the
sir?
best. Don't worry. Okay, go ahead. Okay.
Okay, and I'm thankful to the organizers also. Yeah, during my inaugural session lecture, I could not thank him. Sorry for that. It is really good opportunity for all budding engineers, budding robotists, I will say, that they are getting one platform where they can interact with IIT professors, experienced professors, and they can get their research ideas from these sessions. So I wish you all the best. So let us start discussing this topic, innovations in robotics technology. Just to give you confidence, as I said, that this biodata was little lengthy. So about me, I would like to say that I am a Bureau of Indian Standard PGD 18 committee member who is taking care of robotics and automation related standards. I am with ARMWeb Research Board, which is taking care of robotics and automation related proposals and projects. I am with the Robotics Society of India. Because of SASR, I could become a governing council member. I am also judges, one of the judges over there in the Robocon. It's a national robotics competition. As I said, it is one of the most popular competition in the whole country. Now, I will be presenting basic of robotics first, because this is the very first lecture of the complete course. So let me take you to the introduction of robotics. I will be going very quickly through all these terms. Then my major focus will be on smart robotics, how new innovations and innovative research is happening in the field of grippers, sensor, cameras, batteries, controller, microprocessor, motion control, software simulations, soft robotics, and at the end I will be presenting few most advanced robots, and again I'll be adding little bit statistics how innovation is driving the industry. Okay, so this way will be the flow of my lecture, and it is very clear that you can stop me in between at any moment, at any point of discussion, and you can get clarification about it, or at the end also we can take few questions. So let us start with the introduction. I would like to say that industrial robotics started way back in 1937 when Bill Griffith Taylor, he made one industrial robot. At that time it was known industrial robot over there, and one article was published on that. Then we are coming across another news which was there in 1954. George Devol with Joseph Engelberger, they made first Unimation Corporation robot Unimate, and they started making similar types of robots for the industry. Okay, so this is the first start of the industrial robotics. Then we are seeing that in the Stanford University, Stanford arm was there, and we can see that in 1974, ABB Robotics company, they started making IRB6 robots, which was first of its own type, commercially available electric microprocessor controlled robot. So just to give you little idea how industrial robots got developed, I have presented this fact. So what is system architecture of robot? Everybody knows robot is there with a controller, with teach pendant, with its computer, mainframe computer, so that some simulation facilities can cross-check the correctness of the program, and many integrations can be made possible. Now, history of robot everybody knows. Being a first lecture, I would like to give this basic idea that, see, in 1921, this definition was presented to masses by Karel Capek, and it was in his novel. And in 1941, we could understand the term laws. What was the laws presented by these? What are the definitions? We all know. But we must remember that these definitions are giving us a guideline for many, many things. Even laws. We know all the laws. We all are teachers, technocrats, and we are coming across all these terms. But they are guiding us towards understanding the total frame of research and how to go ahead by keeping them intact. So development of robotics was there. First industrial robot Unimate in 1954, a big robot which was handling.
Excuse me, sir.
Yes.
Sir, sorry to disturb you, sir.
So
I'm not able to send PPTs, sir. Can you share, sir, PPT?
I'm sharing my PPT.
But I'm not
Okay.
able to.
Okay. Just a minute.
Yeah.
Let me do it again. I think now you are able to see that.
Yes.
Yeah, sir. Get it in presentation mode.
Yes, sir.
Yes.
Thank you.
Sorry for that.
Okay.
So development of robotics, first industrial robot Unimate Corporation company, they made first industrial robot who was handling TV picture tube, and to make it a safe handling, it was such a big machine as such. Then 1978 we could see Puma robot developed by Unimation Corporation again, and it was for material handling purpose. Then we are seeing in the 80s, we can see different robots started coming for different applications, and they were all innovative. SCARA for faster assembly work, Cognis for vision-based inspection, Barrett hand for Dexter's handling. This was the phase of new innovative robotics technology, right? Then in 1990s, space explorations also was the area which was covered by robots. We can see Pathfinder, Sojourners, which are the rovers for which were used for Mars explorations. Then what is the need of this all robotics, technology? Basic need is that the types of jobs which are dangerous for human being, which are having D3 type of elements like dust, dirt and danger, that should be eliminated. Everybody of us we know, and to remove them is the first topmost priority behind robotics technology. Even some jobs which are menial, they are unskilled, and we want to remove those. Okay, and these types of job where which are boring, stressful, labor intensive, where human being cannot work properly. For example, spraying operation, where complete vehicle body is getting painted. Second, fountain of sparks, where thousands of spot weldings are being done. So we have understood need of robots and basic philosophy how robots got developed. Now we'll just go to applications so that we will have complete overall view of robotics technology and robotics industry. Then we can easily understand where innovations are happening and how they are important. So what are the applications of robotics? You name area and robots are there, right from agriculture, automobile sector, construction, entertainment, healthcare, laboratories, various different types of research, law enforcement, manufacturing, military operations, mining, transportation, domestic and warehouses. So these applications we all know, and many of them they are increasing the production capacity, they are increasing the safety aspects, they are increasing the simplicity in the functionality, and they are increasing the importance of the robotization in that specific area. Now the types of robots which we have, there are of different types. Stationary robots are there, then we have mobile robots which may be wheeled, which may be legged. Then we have as per their navigation, they can be ground robots, they can be underwater robot, flying robot or amphibian type, mixing of these two according to the size. They can be nano robots, micro robots, giga robots or macro robots, giant robots are there. Then as per their working in a group, they are also separated as a cubic group and swarm robots. Okay, swarm robot, of course, they are having each element as a cubic robot or fractal or modular robot. Some robots, they are getting inspiration from nature. They are referred as biomimetic robots. Some robots, they are hybrid. They are having combination of two different technologies. They are referred as hybrid robots. So these are the different types of robots which are there in the complete robot domain. Lastly, I would like to present the basic information which I am giving you in that session. This is the last information about the industrial robot manufacturer. We must know which are the companies who are actively involved. They are leading the market of robotics. Fanuc, Yasukawa, ABB, Kawasaki, Nachi Company, Denso Robots, Kuka Robots, Mitsubishi, Epson and Staubli. These are first 10 leading companies in the field of robot manufacturing. It is data according to 2018 and I don't think there is a major change. Few more companies are there which should be remembered by their name because they have their different image. They are Kamau, Universal Robotics, then Hyundai Robotics, Kawada Robotics, Tal Bravo, Indian company, then Kinoa Robots in the field of collaborative robots, Franca and Mecademic. These are all companies which are very promising one, and their robots, of course, Universal Robot, which I forgot. It is also a robotic company which is developing collaborative robots and leading the collaborative robots industry. Now we are starting our actual session. Okay. In smart robotics, we are finding many research. In case of smart robotics, we must understand different technologies, but if we classify them as per the different elements of robots, then we can understand them very easily. Grippers or end effectors, then total structure of smart robotics, then sensors, various sensors are being used. Vision, sometimes it is also considered as type of sensor, that is also getting advanced. These are the four basic main component or robotics technology areas where innovations are happening in a huge amount. Then there are innovations in the field of batteries, controllers, microprocessor, motion control, software, soft robotics and group actions. Group actions working together in a collaborative way. Now let us start with the gripper. Collaborative grippers are there, and these grippers are comparatively safe for human worker. Let me show you one video. I hope you are all able to see this video.
Yes, sir.
Okay. Here, robot is being handled with the brain signals. The systems is collecting brain signals and signals are being refined, filtered, and they are getting modified, or you can say finished as per the requirement, and then robots are collecting those for further execution. Sometimes we may not be able to think that this type of innovation is possible, that robots should just work the way we are thinking, so it will be a very fast communication. So this is first innovative technology which I would like to show. Second one, now it is a origami robot gripper. All of you, we know what is origami, and to add the beauty of origami for gripping application is thought by a researcher, and now it is being developed. You can see various paper folds. The way origami is making object from the folding patterns, here they are making patterns such a way that it can grasp any object from understanding its profile, and it can be further handled carefully by gripping it with the help of this origami robot gripper. It is providing proper pressure, proper force, and it is meant for safe handling. Origami inspired design, it is allowing grasping for wide variety of objects. Whatever can be the shape, it will be accommodated over there with uniform pressure over the object.
Hello.
Yes.
Oh, sir, we are not audible.
You are not getting audio?
Yeah. Now
okay.
Please
Now, is that okay?
Yeah. Yes, sir. Continue, please.
Yeah. I have reduced its volume because it is just sound. It is not having any commentary over there.
Okay. Yes, sir. Please continue.
Yeah. Now, by just seeing this film, you might have understood that how different types of grasping is done very easily, very swiftly, and this can help to common people for many applications. In the market, in a restaurant, at different level, we can have use of such a gripper. Assisting robots are a new trend which are coming up very promising way, and this can be a type of technology which can help assisting robots. Okay, so I showed you two different types of gripper. First one, gripper which is getting actuated with the help of brain signal, and second one, gripper which is having its basic technology which can hold object with a uniform pressure, and it can accommodate any different types of any type of profile of that object. Now, different types of grippers can be understood, but understanding the basic concept, understanding the basic technology and adding it to the requirement, to the actual need of the company, of the organization. That is what is the task in front of robotics researchers. Now let us understand one more such type of gripper, which is real smart gripping. These are octopus tentacles. All of us we know. Using octopus tentacles like gripping or holding object is a technology which is very promising one. Now you will say, sir, what is big in this? Try to understand that this cylindrical object is made up of thin sheet. It cannot be handled properly with the mechanical gripper or any other types of bellow type of gripper. It has its own disadvantages. But over here, you can understand that instead of single point contact, it is getting multi-point contact over the object. It is giving additional advantage of increased gripping surface, gripping area, at the same time handling it in a safest way and not applying more pressure on the object. Vacuum pressure on this distributed over these all suction cups will not disturb the object. So that is beauty of the operation. It will not be, it will be taken complete care of the surface of the object. Right. So we have seen this last operation, which I would like to show you again. Yeah, holding a bottle and pouring a water. See, if we are planning to have it with the help of different gripper other than this suction cup gripper, which is octopus tentacles like gripping, it will be very difficult to design the gripper, to have it operated, and to understand and accommodate its structure in the work volume. But this gripper is very flexible and comparatively it is efficient, I can say, while doing the operation quickly. Now this is about gripper. Multi-finger universal gripper are also there, which are shown over there in the picture at the corner of the slide. Everywhere this type of grippers are being added at the end of the arm. Either dual arm robots or industrial robots are using multi-finger grippers. Those are being used for handling small objects or two objects together, or longer objects with the gripper, or sometimes multi-finger gripper are being used for dexterous grasping, where we have to take complete care of object. So these grippers are really helping robotics technology for its advancement from the point of view of its application. Then we will go for next element, that is sensor. Now sensor is a big area. Everybody knows that nowadays many people are working with the brain signals. These brain signals are being collected directly for performing the operation. So using a data of brain activity with the help of EEG and converting it into programming commands is happening in the field of sensors. as a cutting edge technology. So let us understand how this is being done at the research level. It is supervising robots with brain and muscle signal. Now you can see operation over here. Person or user is near to the robot and he is passing some signal, either muscle signal, as you can see blue arrow is there, and brain signal, which is rectifying the action. And this action altogether is comparatively delicate operation. Pointing a drilling machine to that location is comparatively difficult. Even with the help of teach pendant, it can be jogging operation, it can be maybe hunting mode, but it will not be smooth operation. Now you can see how this operation, though it is difficult, being very easy, being made easier with the help of this technology. Robot is getting signal. EEG cap is there on the user head, and to collect muscle signal, EMG electrodes are there. Unconsciously, many signals are being passed by brain. Those need to be filtered. So different gestures and brain signals can work together for completing this activity. This type of collaborative action of the two different types of sensor is again a challenge. So this system is simple plug and play, and user can control without retraining the robot system. This is a Baxter robot, which is very popular for many R&D activities. Now, what do you think? Is it not a really promising one? Yes, it is a promising activity and it is helping many people for developing new applications, because most of the times making a program or controlling a robot is very, very difficult. But if you can pass what you want directly from brain to the robot, then I think it will be saving a lot of time. And that too, here it is mentioned that the machine learning algorithm is enabling the system to classify brain waves in simply 10 to 30 milliseconds. So understanding of brain wave is becoming simpler nowadays, and this is another promising area. Then there is a camera or vision related technology. Helping autonomous vehicles to see around the corner is a task nowadays in front of all leading automobile industrial or automobile manufacturers. Now, all of us, we have seen complete autonomous vehicles. Either they are being used for traveling on the road or for the cruise control. But various elements and sensors which are there along with the camera, they are being mentioned over here. They have video cameras in the vehicle which are detecting traffic lights, road signals, and keeping track of a car vehicle on the road with respect to other vehicle. Okay, and even taking care of pedestrian. Similarly, it has a lidar. Lidar is light detection and ranging. These sensors are collecting the reflected pulses of a light from surroundings and understanding what is there around that car, so that it makes car easy to understand the distance between that object and car. Second type of sensor, most important sensor in this technology, is GPS, Global Positioning System. And as we know, by taking help from GPS, we can understand various features like where turn will come, where will be a heavy traffic, where can be the signal, and many things. And accordingly, path or navigation can be planned. Then in front of the car, they are showing that radar sensors are there. They are monitoring again a position of vehicle with the nearby other vehicles. And these sensors are there again useful for cruise control. Then central computing system, central computer rather, it will be manipulating the steering activity, accelerator activity, and brakes activity, and it will be controlling whole navigation. Ultrasonic sensors, radar sensors, these are also supporting to the main action of that of the video camera and lidar. Now, how this is helpful for research? Presently, in India, very less research is being done for making such a vehicle completely autonomous and possible for common transportation. For common transportation, many challenges are there on the Indian roads. At the same time, few cars which are having semi-autonomous control, those are being tried over there in the Indian scenario. So this is third area, that is camera or vision. I have many videos to show you, but I am restricting myself and I am selecting very few robots to show you over here. Then in the industrial robotics domain, one new trend is coming very quickly. It is collaborative robots for welding. What is collaboration? All of us, we know that working with robot in its work volume is a collaboration. And that collaborative robot, those robots are being referred as collaborative robots, which are allowing us this type of movement in its work volume. It is safe collaboration. Whenever there is a collision, robot will stop its movements. It is easy for handling. It is compatible with the other devices, and its repeatability is excellent. And at the same time, it is very safe. Now, these collaborative robots for welding, I would like to show you one video over here. The collaborative technology which I said is about robot and human being, but over here 3 robots are working together. It is inter-robotic collaboration, we can say. Now first robot is lifting a cylinder and positioning it for further process. Second robot is bringing small cylinder and arranging it near to the first cylinder. This is a welding which is immediately starting over there as per the requirement. And remember, welding for 3D profile is very difficult, and it's a joining of one cylinder to another cylinder. So its common boundary, common profile or penetration curve can be very complicated for the robot to complete with the help of this welding operation. So welding head is being moved. Even robots which are holding those pipes, they are also moving. This is a real challenge when robots are working together. You may think that this type of operations may not be there in the industry. Okay, only welding can be done very easily. But believe me, collaborative robots are really required. 2 to 3 robots working together. Okay, now you see intelligence level which is being added over here for the same operation. earlier was small cylinder to big cylinder, but now robots are changing their action. Instead of continuous welding, now something else will be done. Let us observe that very carefully. This is a first spot, second spot, third spot, and fourth spot. Now, after completing this fourth spot, you can see that remaining welding operation is being completed very neatly, exactly similar to that of the earlier welding operation. Now let us have a closer look to those welding runs which are completed with a different work pattern. Now we'll have a close look, and here you can see you cannot identify which one was the first one and second one, with the help of spot welding and without spot welding. Both are being completed very neatly. Okay, so this tells us that if human being or if trained labor is doing this work, he may be able to do first job very carefully, but for doing such a similar type of operation for 100 plus jobs or maybe 50 plus jobs, it will be very difficult. But machine can do tirelessly and without any error. So this is a beauty of robots working together. Robots working together is really required, and group robotics is being developed in many industries. Now I would like to show you different types of technology, latest technology in the area of industrial robotics. Because of this, we can understand what are the new things which are happening over there in the industry. Very first one, fast brick laying robots. Bricks are being provided from the backside, and they are being laid in one arrangement. Bricks are being taken from storage and to the required location by the efficient system. So this is one of the area where robots are being used for quicker constructions. Proper laying of brick is taking a lot of time for its planning, its execution and material handling and all. But if it is done by robots, it will be very quick.
Hello.
We have seen first operation that was for brick laying operation. It is quick as well as accurate. Okay, it is required for many purposes. For huge construction to small cottages construction, it can be helpful. Now we are seeing second application. It is again a very challenging one, where we are observing many different types of metallic, non-metallic objects on the conveyor belt, and sorting is very tedious task. Sorting can be there for recycling, it can be there for inspection and correction maybe, and it is a very tedious task, but robot can do it very quickly with the help of camera technology or visions. You can see they are separating out, and the sorting is being done very efficient. They are collecting wooden parts, metallic parts. Now here you may think that many of the parts are being overlooked by the robot, but it is not like that. The parts which are pre-identified, they are being carried away with the help of conveyor belt, and the parts which are needed to be separated from the other objects, they are being separated and collected and even added in a different bins. They are getting added as per the requirement. Now this is next type of technology which I would like to present over here. The way I said that 3 robots are working together. Now it is 4 robots and they are working for welding operation again. This welding of 3D profile is very challenging. Holding it, making its fixture, instead of that, holding it as if 2 people are holding that and 2 people are building that, that is more easier for programming as well as for completing its task. These all robots are 7-axis robots. They're having serpentine motion. They can hold object very efficiently and in a very flexible way. Now over here, another building operation we have seen. Again, one more construction robot where concrete is being laid, concrete is being properly arranged such a way that it is becoming wall. And the basic concept of 3D printing or rapid prototyping type of thing, material additive manufacturing, I would like to say over here, that basic principle of additive manufacturing is being used, that layer by layer it will be arranged such a way that the complete object will be something different. Now a complete room is being made with the help of concrete printing machine. And you can see that these types of walls which are having air inside will be giving additional advantage from the uh, construction point of view. It will be having a wall with the proper surface which can be finished again. This quicker construction can be helpful for many different applications. Okay, so you can see these type of operations are possible. These are the construction which are completed with the 3D printing concrete robotic machine. Okay, we cannot believe on it, but it is a fact that constructions are being made with the help of this technology. Now milling robotics, simple milling operation, milling machines, NC milling machines, we are comfortable with those all terms, but robot being used for huge milling operation is another technology where many things are happening. This is milling robot by Kuka, and it is doing big milling operation.
Hello.
Yes.
Oh, sir, we are getting interrupted voice.
Okay. Okay. I'm having good connectivity over here.
Okay, sir, please continue.
Yes. Okay. So the last type, palletizing. Whatever operations we have seen, they are something new than our conventional applications. For robot palletizing, in the many industry, we know that it is being done for carton handling, box handling, packages handling. But you can see over here how operations are being done for these bricks, and this palleting is being done so that it is in a group. It is not one object at a time. And even certain pattern is being referred for its lifting. Sometimes it is lifting 3, sometimes it is lifting 2. It all depends upon the type of combination it requires. This is for material handling purpose. So we have seen different new technologies which are there for industrial robot. Now there must be a question in everybody's mind that what can be future technologies then, where we will be getting more sophisticated robots. So let us understand the future of this industrial robotics. New robotic arm technologies are coming up in the market. The first I would like to present over here in the session of future technology is dual arm robotics. Dual arm robots, which I showed you in the initial slide, they are being used very efficiently for material handling. Now it is working for some assembly operation. Small bulbs are being properly getting attached to the cap, holding it, turning it, rotating it properly. This is ABP Yumi assembly robot. We will be giving similar accuracy of that human being. Sorting can be done, testing can be done, and assembly will be completed very efficiently. Now, the first one which we have seen, it is about use of dual arm robot. Now I am showing you industrial robot for milling operation. KUKA robot is being used for its milling operation, and it is carving a shape of octopus from wooden block. Okay, we don't have time, so I thought I should take you very quickly for that, and we can see the finished octopus which is being made at the end of this operation. Okay, step by step a material is getting removed and it is completing octopus at the end like this. Okay, so it's very efficient milling, which is getting a job. All is object. Now Franca Imica is a robot which I would like to present you. You will be surprised to see that it is having its skin which is very sensitive, and it takes all types of movements just by understanding what pressure is applied to its linkages. Collaborative robot is a technology which is developing very rapidly, and person is being allowed to work. Hello.
Excuse me, sir.
Hello. Yes.
Hello, sir.
Sir,
I am able to see only one slide. I think you are moving slides, or that only one slide you are explaining, sir.
No, I'm showing you a
I
video.
can see the collaborative robotics for welding. Only that slide I am able to see, sir.
But I'm showing you videos. Others are able to see that video. What about you?
No, sir, I am unable to see. What about other participants?
Yeah, we are seeing over, sir.
Sir,
Yeah,
we
but
can't see the video.
you could not see the video?
Yes, sir, we couldn't see the
No,
video.
sir. No, sir.
Okay, okay. Now again, I'm trying to show you video.
Okay.
Is it visible now?
No, till it is
No,
on
sir.
presentation mode slide.
Okay, 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 okay. But I'm sharing the screen. Could you able to see the earlier videos? Hello?
No, sir. No, sir. No, sir.
Oh, you should have told me earlier. I was thinking that you are seeing those videos.
So we thought a network error in our side.
Okay, okay, okay. See, I'm showing you videos step by step. Are you able to see the voice? But it is showing me that I am showing videos properly. See,
No, sir, we are not getting.
Okay, okay, okay. So let me try again. Okay, let me start sharing a screen. Then only I think you can see that.
Yeah, yeah, entire screen. Yes, sir.
Entire
Exactly.
screen. Okay, okay. I'll do that then. Okay, I'm sharing a screen, and now I'm sharing that video. Okay. So this is a future technology.
Yes, yes, sir. We are getting it.
Okay.
Yes,
Okay.
now
Sorry
we
for that. Then what I'll do, I will quickly show you all those videos again. Okay. Very first is collaborative robots working together. Are you able to see the screen now?
Yes, sir. Yes, sir.
Yes, sir. Yes.
I think this video you might have not seen. So I'll quickly complete this. So robot completing welding operation for the cylinders, one horizontal cylinder and two small cylinders. And for the first cylinder, it has completed the operation over here. Now it is completing welding operation now. And it is giving only 4 spots. And you can see now the profile of welding which has got completed. Now you see the beauty of the operation, how nicely this welding has been done for both the cases, initially without spot welding and now with spot welding. Okay, the next video I am showing you, yeah, it was all about bricklaying. So bricklaying robots, I'm going a bit quickly, sorry I missed that. Then sorting operation, sorting metallic and non-metallic things in a different way. Then 4 robots working together for welding operation. They are having 7 degrees of freedom. Then cement spraying, cement printing robotic machine. It is making a wall by simply dispensing cement at certain rate and making it layer by layer. So this type of construction can be completed. Then milling robots, huge milling operations can be completed by this robot. Then palletizing, different types of brickworks can be handled very effectively. This I showed you, and the next, yeah, and the next one which we were discussing now, future technology. In case of future technology, I am trying to show you ABB Yumi robot, which is doing this assembly operation. ABB Yumi is holding that bulb, testing it at this location, and then putting a cap. Testing over here, if it is okay, then fitting it for the next operation. This is giving a feel of assembly by human being. Then wheeling operation by robot. Yeah, so you can see skill of programming where octopus is made with the help of milling operation. Next is very important operation. Robot is understanding its lead through operation. Okay, manually it will be taken for certain work, then those positions will be recorded and robots will be completing further operation. This is Franklin robot, and it has very advanced sensor so that it automatically understands reaction of the object and controls its force for various assembly operation and in a very close vicinity of the arm. It will be more easier programming than the conventional industrial robot programming. Again, instead of only 2 hours, dual arm or single arm, we see group of robots working together for certain applications. Collision avoidance, like force or assembly. These are the features of this robot. So these are the smart we have various research in this field. Okay, sorry for that. I was thinking that I am showing you video. Thanks for reminding me. So many facts I can present in front of you on the basis of statistics and showing you different robots. But yes, new research are being planned and they are right from logistics up to industrial operations and even in a domestic market and some newer type of applications. New level of smart industrial robots are coming. I would like to show you one smart robot, which is really good one to see. Is DoBot. It is required for all of us as an academician. It is a desktop robot, and it can help you right from making your breakfast up to learning various types of sensor. Okay, this robot is a simple desktop robot. Yeah, I'll go little quickly. You can find these videos on the website, on the internet. The website of Dobot, it is available. It can do laser cutting. It can do different types of artistic work. Now it is doing rapid prototyping. Gesture motion controlling is also possible. Oral instructions also it can take. Brain signal also it can take and it can work accordingly. Then we have dual arm robot, similar that we have seen earlier. But again, taking inputs from the gesture, and it is working with real time. Programming becomes easier. And CNC milling, instead of CNC milling, we can use robot for milling operation and even 3D printing operation. It can be used for assembly operation, painting, laser engraving. Yeah, many smart robots you can see over there. Now I believe that I could take you to the cutting edge technology, to the newer concepts in the field of industrial robotics. If you want to go to different websites, these are the websites from where you can get the more details, more appropriate, authentic details. So I think I have presented what I know. I may have lesser knowledge because everybody cannot be complete with the all knowledge and all information. So even you can help me by asking questions. So are you ready to help me by asking questions? Can we have interaction session?
Yes, sir. After at the end, participant can ask.
Okay. So I'm stopping my presentation. Now you are allowed to ask me question, please.
Okay. So it is my request to all participants. Please, if you have any question, unmute yourself and ask. Sir is ready for that.
I think there can be two messages from your side. One, that you have understood everything, or second can be you are not happy with what I have presented. So either ways, you give me your feedback, and whatever changes are required, I'll make changes in the PPT. I have presented all the facts which are very recent, which are based on the information. You can get all the information on the net, and you can make yourself able to search which are niche areas, which are cutting edge technology areas, which are recent innovative technologies coming up in the field of robotics.
Yes.
Yeah, Thora sir, I think if there is no any question, we will stop over here.
So there is question from my side.
Even you can give.
Sir, when we are looking toward this by dual robot arm, sorry, it's a dual arm robot. So how we can get control on their activity?
Having echo. Two devices are there near to you.
Hello.
Yes, you can go ahead. Any problem with audio system?
I think so it's working. Hello.
Yeah, Thora sir,
Sir,
you are audible. You are audible. Please
okay,
go ahead.
Okay. So I'm right now. I'm moving toward the vote of thanks. So I, Professor Yuvraj Thora from Department of Mechanical Engineering, Bharati Vidyapeeth, deemed to be University. I would like to express my profound and heartfelt gratitude to our honorable guest, Dr. S.S. Oversar, for sparing us the time out of his busy schedule to address us, to guide us, and inspire us on today's whatever the input and insight. So this has been a very informative and joyful journey that we have gone through things like smart robotics, advanced robotics applications, innovations in robot technology, collaborative robots, especially in welding, and future technologies in industrial robot and sir has been shown some of the videos that we could understand very properly. So it is a great privilege to having you here and this opportunity for the sharing experience with us. At last, I would like to extend my sincere thanks to all the participants for making this session more interactive and it could offer. Also, I thank to our sir, not only again to Principal Dr. A.R. Bhalerao and HOD Mechanical Dr. K.B. Sutar sir to have organizing this kind of such a wonderful FDP. It has been a great pleasure to have all of you. Once again, thank to all. Thank you very much.
Thank you, everybody. All the best to all of you. Thank you.
Yes, sir. Thank you. So,
Thank you, sir.
one more announcement to the all participants. We have another session at 1 o'clock. That is Introduction to Robotics, and it will be guided us by Dr. Ravi Kumar Mandwa from NIT Bhopal. So be ready on that. Thank you.
Thank you, sir.